Google has once again redefined the boundaries of artificial intelligence and robotics with the groundbreaking release of Gemini Robotics, an on-device autonomous robot brain that integrates the full power of its multimodal Gemini AI models directly into robotic systems, enabling real-time decision-making without cloud dependency, a technological leap that promises to revolutionize industries from manufacturing and healthcare to domestic assistance and autonomous vehicles. Unlike traditional robotics frameworks that rely on pre-programmed behaviors or constant cloud connectivity for processing sensor data, Gemini Robotics operates with full autonomy at the edge, combining advanced computer vision, natural language understanding, and predictive movement planning in a single energy-efficient package small enough to embed in everything from industrial arms to household robots. At its core lies a neuromorphic processing unit, NPU, optimized for Google's path-breaking Gemini Nano architecture, allowing robots to process high-resolution camera feeds, LiDAR data, microphone arrays, and even tactile sensor inputs simultaneously. While drawing less power than a smartphone, this means a Gemini-powered robot can recognize objects, interpret voice commands, navigate dynamic environments, and manipulate tools with human-like adaptability, all while operating offline in sensitive or remote environments where cloud access is unreliable or prohibited. Early demonstrations have stunned observers. Prototype robots equipped with Gemini autonomously assembled complex electronics using verbal instructions alone, diagnosed mechanical failures in factory equipment by correlating thermal imaging with maintenance manuals, and even improvised tools from scrap materials when original parts were unavailable. Capabilities that until now required human intuition. What sets Gemini Robotics apart is its multimodal embodiment learning, where the AI doesn't just process sensory data, but develops a proprioceptive sense of physical existence, understanding how its actions alter the environment and vice versa. This is achieved through self-supervised training in simulated physics environments, a technique Google calls Hyperion dreaming, followed by real-world fine-tuning, allowing the system to generalize skills across different robotic forms, whether a quadrupedal bot needs to climb rubble or a robotic arm must adjust grip strength for fragile objects. The implications are profound. Whereas most industrial robots today perform only rigid, repetitive tasks, Gemini-enabled machines can adapt to unforeseen variables like changing light conditions, damaged tools, or unfamiliar objects by drawing on a world model that continuously updates based on sensor feedback. In healthcare applications, test units have demonstrated real-time surgical assistance by interpreting MRI scans mid-procedure to adjust robotic scalpel paths, while agricultural models distinguish crops from weeds and precisely administer pesticides without pre-programmed field maps. Perhaps most impressively, these robots exhibit meta-learning. A Gemini-powered kitchen assistant observed in Google's labs went from clumsily handling utensils to perfectly flipping pancakes after just 3 failed attempts, having internally refined its motor control algorithms through embodied trial and error. The on-device processing capability addresses long-standing hurdles in robotics: latency, privacy, and reliability. By keeping all computation local, Gemini Robotics eliminates the 100–300 millisecond delays inherent in cloud-dependent systems, critical for applications like autonomous drones avoiding power lines or collaborative robots, cobots, working alongside humans. Medical and military applications particularly benefit from zero data transmission, ensuring patient records or tactical information never leaves the robot's secure hardware. Google achieves this through quantum-inspired pruning algorithms that compress Gemini's trillion-parameter knowledge into specialized skill capsules, small enough to run on edge devices, yet retain the model's full reasoning prowess for assigned tasks. Each robot loads only relevant capsules. A warehouse picker might need object geometry understanding and inventory management logic, while a disaster response bot carries debris navigation and victim detection modules, with the ability to securely download new capabilities over the air when requirements change. This modular approach also enables swarm intelligence. Multiple Gemini robots can share learned behaviors peer-to-peer via ultra-wideband mesh networks, creating emergent collective intelligence without centralized control demonstrated when 20 simple bots collaboratively rebuilt a collapsed bridge structure by adapting roles in real time. Under the hood, Gemini Robotics leverages three breakthrough technologies. 1. Diffusive motor control, where AI generates thousands of potential movement sequences in parallel, like a chess engine evaluating moves, before executing the optimal trajectory, enabling fluid adaptation if obstacles appear mid-action. 2. Cross-modal attention fields, allowing the robot to correlate inputs from different sensors, for example, matching a voice command, "Hand me the spark plug," with visual identification of the correct part in a cluttered toolbox. And 3. Embodied constitutional AI, an ethical framework that constrains actions based on embedded safety protocols, preventing a Gemini robot from obeying dangerous commands or autonomously modifying its core directives. The hardware platform combines Google's Tensor G3 processors with custom optical accelerators for real-time vision processing and haptic feedback loops that provide millisecond-level adjustments to force-sensitive tasks like inserting microchips or handling fragile objects. Industry reactions have been seismic. Manufacturers predict 50% faster production line reconfigurations since Gemini robots can be verbally instructed rather than manually reprogrammed, while logistics giants anticipate autonomous loading docks that self-organize based on shipment contents. Healthcare providers are testing bedside care robots that understand complex patient needs, like adjusting IV drip rates based on verbal symptom reports, and smart cities may deploy maintenance fleets that independently identify and repair infrastructure issues. Even consumer applications abound. Imagine a home robot that not only cleans but anticipates needs, noticing expired milk and adding it to the shopping list, then unpacking groceries upon delivery while avoiding the cat. However, such capability raises ethical and security concerns. The same embodiment that allows surgical precision could be weaponized, while skill capsule piracy might lead to black market robotics hacking. Google has implemented biometric binding tying each robot's AI to authorized users via facial voice recognition and geofenced operation. Workforce disruption is inevitable. Gemini Robotics could automate 40 to 60% of current manual labor tasks within a decade, necessitating urgent policy responses. As Google opens early access to select partners, the race is on to harness this technology responsibly. Gemini Robotics doesn't just represent smarter machines, it heralds a world where physical and digital intelligence merge, creating autonomous agents that perceive, reason, and act in our environment with near-human versatility. The question is no longer what robots can do, but how humanity will adapt when they can do almost anything.